Okay, it will spin on its own orbit and it will rotate. Okay, that is the case. So if you talk about the intrinsic spin of electron and angular momentum, and we have to take into account of spin angular momentum values, that is S values. So orbital angular momentum and as well as spin angular momentum values should be taken into account. That is capital L values and capital S values. Okay, so likewise, orbital angular momentum is capital L equal to L into small l into L plus 1 by h by 2 pi. Similarly, if we talk about spin angular momentum, it is capital S into S plus 1 root of S into S plus 1 into h by 2 pi. So the spin quantum numbers, the spin value may be either, it may be a positive or plus half or minus half values. Okay. So if we talk about the complete wave function, okay, in terms of angular momentum or in terms of quantum numbers, it can be given as pi of n, L, m, and S also should be taken into account by providing the spin values for the because the electron used to have the charge of plus half or minus half. So in addition to the n, L, and m, here you have to add the S value also. So there is a wave function with respect to n, L, m, and n of S value to be taken, and this function is called as a spin orbit functions. So spin orbit function means that is, since the electron is revolving around the nucleus, so you have to take both the orbital angular momentum and spin angular momentum, and that by spin orbit functions is taken. And if you talk about the spin angular momentum, it used to have the three components like x, y, and z coordinates. So among the three, one of the components may be well defined. That is normally that is SZ will be well defined. It used to have the plus half of h by 2 pi or minus half of h by 2 pi may be present. So ns value may be retained as plus half h by 2 pi with respect to alpha, or the same value with respect to minus in terms of beta. Okay, alpha values and beta value may be defined with respect to spin functions. That is the values with respect to ns will be called as an eigenvalue, and it is n of s is correspond to its eigenfunctions. Okay, so these functions may satisfy the following equations. That is either it may be it used to have plus values or minus value with respect to alpha s or beta s, and thereby we can take into the picture that is how the orbital and spin functions are taken in terms of studying the electronic spin. So if you just check about the kind of motions, that is, it says that using these values, obviously, it is possible to calculate the eigenvalues with respect to S of Z, alpha, and beta values. So here, using this content, it is possible to use and measure the wave functions for many electron systems or many atoms by taking into the account of both the electronic motions and the nuclear motions, as well as orbital angular momentum and spin angular momentum values. So that should be taken. And if you take both the electron and nuclear motion, means the problem here starts like the electron itself will have the electron-electron attraction or repulsion, followed by nucleus itself. It may used to have both nuclear attractions or repulsion, nucleus electron attractions or repulsions. So all the terms should be taken into account. Okay, so if it is only a particle or okay, so in terms of a charged particle means, and if it retains as such, there is no problem. In the case of electron in a kind of atom or molecule, so it is revolving around the nucleus and it is a charged material, and thereby, so it used to have a kind of attractive forces and as well as the repulsive forces. So we have to take into the account of both in terms of, okay, so if you talk about the case for any systems like hydrogen-like atoms or helium-like atoms, obviously, we have to take into the account of the intra-nuclear attractive repulsive forces or intra-electron attractive repulsive forces and etc. So all those content should be taken into the account in order to check it out. So here, in terms of one electron systems or many electron systems, here we will assume that in the case of many electron, we just assume that it is like a kind of individual entity. Okay, let us think that helium has 2 electrons. Okay, So the 2 electron is, we used to think like it is a kind of a 2 hydrogen atoms. Okay, so that is we use normally in quantum mechanics the we approximated the approximated wave function for many electron atoms is normally used to take as a product of 1 electrons, or electron functions are product of hydrogen like atoms eigenfunctions. So like many electron systems may be accounted by means of some negative atoms. Okay, sum of 1 electron, what is the charges like attractive repulsive forces and the second electron. Okay, we are ignoring the term like between the electron and electron, or electron and the second nucleus, or the second nucleus and the first electron, and those kind of in order to minimize the complexity. Okay, so we just take 1 electron, and it is additive of 1 electron. So if you take 5 electrons means obviously all the 5 electrons are different. So we just take summation of 1 electron into 5 times. Okay, that is a product of 5 into 1 electron kind of activities will be assumed that now in order to find the kind of wave functions. Okay, so the approximate energy for many electron systems is nothing but the sum of 1 electron systems. Okay, that is the concept used to build it in terms of in order to study the quantum mechanics. Okay, so here if you want to study in terms the electronic spins values in terms of symmetric or antisymmetric, before that we have to check it about how about the determinant wave functions like Slater determinants. That is very important. Okay, so you should know about Wording by Slater determinants or determinant wave functions. That is how the linear combination of electrons are arranged, or how about the overall wave functions, etc. So what the Pauli's exclusion principle says that the overall wave functions of a systems should be antisymmetric. Okay, so with respect to the interchange of position and okay, so of every pair of electrons. So that is the cases. So thereby, okay, so it is not the only possible things. Thereby, we have to use the kind of things. So let us assume that the molecule or the atom used to have 2 electrons. Okay, so the 2 electrons means we can give the wave functions of 1 electron as pi1 and a second electron as pi2. That is the complete wave functions for electron 1 and electron 2, etc. So according to, as I told you, 1 electron approximation. So here 2 into 1 electron of approximation should be taken. We should not take electron 1 and electron 2. We have to take 1 electron and the corresponding wave functions, and it should be multiplied by 2. That is the case. So according to 1 electron approximation, the approximate wave functions for 1 electron for many electron system is given as the wave function of 1, 2, 3, etc. is called as pi of 1 and pi of 2 and pi of 3 and etc. for many electron systems. If it is only 2 electron means it should be restricted as a pi of 1 into pi of 2. Okay, if it is a 4 electron, it should be going up to 4, or if it is up to n electron means it should be go up to n of n. Okay, so since the electrons are, it is not possible to indistinguishable and equal good wave functions is obtained by interchanging the electron. Okay, let us assume that electron 1 and 2. Okay, so because it is not possible to distinguish between these two, so that the electron 1 and 2 maybe also can be called as electron 2 and 1 and etc. Okay, so it is equally a good overall wave functions for many electron systems using the n factorial for such product functions, and all these product functions are equally probable as approximate wave functions for many electron systems. Hence, the most general wave functions will be, as I told you, that is a linear combination of the n factorial of the products, and there will be a linear combination of linear combinations of factorial. Okay, so since in all these cases, okay, the identification of a complete combination is a little bit tedious, and thereby, okay, we can answer the questions given by Pauli's, that is called as a Pauli's principle, and is what it states means the overall wave function of a systems must be antisymmetric with respect to the interchange of positions or coordinates of every pair of electrons. So that is the cases, and thereby, so here we can say that the overall wave functions can be, okay, so either